Okay, so there we go. There we go. Let me just make it bigger. There we go. We are talking reinforced concrete detailing. When we speak about detailing, we are actually speaking about the reinforcement that should be done in the beam. Now, we're going to be doing a beam, but it's more or less the same kind of stuff when you consider the slabs, and the retaining walls reinforcement is always the same. Okay. All right, so this is the end goal. Okay, so if you look at this picture over here, what we have is that you have a wall here and a wall there that is supporting this beam over here. Now, this beam has main bars. There's a main bar. A main bar is the main reinforcement, which is usually this one that goes like that. Okay. And then it also has links. So links are these ones that form like a square shape or rectangular shape. Okay. And then we have top steel bars or hanger bars. So these are the ones that are on top and that, you know, span like that on top of the beam. So the main bar at the bottom, the top steel at the top of the beam, and then links, you know, just connecting the two. All right, as you can see them over there. All right, but let's get into let's study it slowly, step by step, because for now we're not gonna be talking about designing the steel. We just want to talk about actually drawing it, because remember in N4 you were just drawing the beam as it is without any detailing inside, without any reinforcement inside. So right now, what we want to learn is how to draw the reinforcements. Don't worry too much about the design. We'll do the design of the bars much later. For now, we just want to get you to know how to draw them. Okay, so this is the question. It says, draw a fully detailed reinforcing drawing, including a representative section and a bending schedule. We'll get to talk about what a bending schedule is, but we'll start with the representative section. For the 230 by 550 millimeter continuous beam on grid line 1. Okay, so that's grid line 1. If you look, it's a continuous beam, because remember we spoke about this last week, that a continuous beam has 3 or more supports. Okay, so we've got a support there, we've got another one there, and then we've got another one there, so it's continuous. Okay, and that is why it's been labeled the 230 by 550 reinforcing is going on top of that. Remember, this is a top view when we look at it from the top, so we can see that support there, that this is a column right over there. Then on top of the column, you then have the beam continuous going that way. Okay. Boom. What else? The beam is supported by 230 by 230 reinforced concrete beam columns. So the beam is actually 230 by 230, right? I mean concrete column, not the beam, the column, sorry. The column is 230 by 230 in dimension. So it's 230 this way and 230 that way. Okay, Use the layout and bar size it as given in figure 2 and include R 10 stirrups. Stirrups are those hangers that are connecting the square ones. We will see them at 250 millimeter centers. So this is just the spacing between them. So, okay, so this is for spacing. This is for spacing. They're talking about spacing right over there. The concrete cover now is 30 millimeters. Okay, so the concrete cover is the distance between the end of the beam and the start of the bars. Okay, so for example, the beam ends over there, so probably the bars start over there. So the spacing here is what we call the spacing there is what we call the cover, but you get to see it more. The concrete strength is 25 MPa. So this just details. Okay, now this is what they give you in the question, right? Now let's go start and actually draw this the way they want it. Oh, just for interest's sake, so you've got the columns over there and the beams, and then this space in the middle, that's where you then put your concrete slab. Okay, there, over there. That's your concrete slab. It's going on top of the beam. Okay, and your beam then, as you can see, is that. Cool. Let's move on. Okay, so this is the end goal once again, but like I said, let's take it one step by step. This is just the side view. This is the side view because remember, the first one that we looked at was the top view. Okay, now let's start with the beam. Now, what we have here is the actual beam from the side view once again. These are the columns that we're talking about, that they are 230 by 230. They are square columns. And then this is the beam. They gave us the dimension of this beam. They said it's 550. Okay, so, you know, in thickness. I can't remember the other dimension. Oh, there it is. It's a 550 by 230 beam. So we can see the 550, but we can't see the 230 because we'd have it would have to be, we'd see it from the top view. Okay, so first of all, that's where we start. We start with the beam, drawing the beam and the columns. Okay, remember the question was to draw all of this. So this is where you start. Start with this very simply. Okay, there we go. This is the top view. I mean, this is still the side view, the front, or rather, it's called the front view of the beam. So if you want to consider the beam on its own, remember, this is the dimension of 550 there. Okay. And then what we're going to start with then is the reinforcing, the main bar. Okay, don't worry about the naming of it. We'll get to that when we speak about the bending schedule. But for now, what I just want to say is that once you've drawn the beam, right, you put your main bars at the bottom. Okay, these are the main bar. That's the main bar. So what I want to bring to your attention is that if you look from this side of the beam, you will still see the 550, because remember it's 550. But if you look on the other side, you will then see the 230, and you will see the main bars once again right over there. That's the main bar. It's the same main bar as demonstrated over there. Okay, so it's just a difference of views depending on which view you are using. Okay, let's move on. Don't worry about this. This is just part of the design. This is just a bending moment diagram. We'll speak about this in detail when we get to design the actual reinforcing. Okay, and also don't worry about curtailment, but the purpose of this is just to show you that curtailment is just the distance between the column and the start of where you put your bars. Okay, so all of these things are calculated. You don't just start and end anywhere you want. It has to be a precise calculation. Okay, let's move on. Once again, just a design. Curtailment now from this side, calculated precisely. Now, this is what we then call a bending moment schedule. Okay, I just want to check something. We're on the right slide. Yes. Okay, so this is what we call a bending moment schedule. This is where you put the member mark, size, or number off. Okay, so that's where you put the member, and then number of each, the actual. Okay, this is the member, because it identifies also where the reinforcing is going to be, and then you have the actual reinforcement over there. So all these things are just describing the actual bar. Okay, its length, its size, how many of them, total number of them, and all of that. And then also here, it's then describing the dimension of the actual member. All of them come with a shape code. If it's just straight like that, it has a different shape code. If it's this kind, that's like that. Got little kinks at each end. It has its own shape code, and all of that. And then finally, the mass of it, how heavy it is. Okay, so that's just to understand. Like I said, this is then what we call the bending schedule. Cool. All right, so moving on. So you then put beam number one, the size of it, and all of that. Okay, don't worry about it too much. It depends. When the question is given to you, you will also be given how exactly to what information you should put that's relevant, because not all of this information is relevant for this particular beam. But just to understand these numbers, there is a total number of 4 of them. Okay, there's 4 of the bars of the reinforcement. They are, so you would write it like this. There's 4 of them, and then the size, because they come in different sizes, the size of it is it's called a Y25 size. Okay, and then the mark is just to say it's the first one, there's a second one, and then the length of it is 4650 millimeters. So the length of it, how long the bar actually is. Okay, in that direction. And then the shape code, the shape code 20. There's a table of the shape codes and all of that, and there's a table of the sizes. You get to see it, and the dimension of it, well, it's not always going to be A, it's going to be 4650, but this A, B, C, D, it depends on the shape of it. So you'll find that, for example, if you have a kink, this one, you'll find that this one is A, and perhaps that side is B, and that's B because they're the same. So that's how it is. So if it's straight like that, then it only has A. It doesn't have B. That's why there's only one of it. Okay. So that's the total length of it. In this total, you find it by saying 4650 times 4. They should be times 4 because there's 4 of them, right? Yeah, there's 4 of them. So you multiply, if you multiply that number by the total number, then you should get the total length. Okay. And then the mass, you just go read it off from the table as shown here. It's read off. For this one, you had to calculate it. These are just standard dimensions for rounds, but there are tables where you just read it off the total mass, where you don't have to calculate it. Okay, so you just write the total over there. It's your bending schedule. All right, so just continuing with the reinforcement. As you can see here, there is this reinforcing that's put on top. Remember, we started with this one. Now, this lap length, it's also calculated. You don't just put any lap length that you like, but this is just to demonstrate that you also have to put another bar, you know, close to the main bar, which then takes it to the end of the beam. Okay, that bar now, the lap length, as you can see, this is another bending schedule, which is a little bit different from the first one. That's why I was saying to you, don't worry about the information so much, because even in the questions, they will tell you what information they want. But here, it's a Y25 bar, just to read off. These are the dimensions of it, the diameter. It's a Y20. What's going on here? Anyway, it's different information that's given here. You're just gonna read off the one that you want based on the question that has been asked. Okay, so this one is a shape code. This type of bar that goes to the end, it's a shape code 34. It's got a dimension of A and also an N. So to get the total length of it, A is given as 155, and then A is given as 140. You add it, you get the total length of it. That's it. There it is again. It has an L now and an N. So there we go. N is given 140. The size of the bar, how thick it is, you just read it off the table. Okay, these are just some tables that you need to familiarize yourself with. They would be given to you. All you have to do is learn how to read them off. The question will tell you exactly what you should read off from the tables. There are many different types of tables with different types of information that you need to know, but you are going to have to just read it off. Okay, so this is just a continuation of the first table that we started with. We are now adding the other bar. There is 4 of them. It's a Y20 bar with the shape code of 34. Okay, remember the Y20, the 20 refers, or the 25 from the first one, it refers to the thickness, the diameter of that bar. Okay, so moving on. All right, so we've put this one, we put the main bar there, and then we've put the end bar there. Now we are putting the middle bar, that one. Okay, and at the end of the other one, we put that one. What I want you to notice is that the main bars, they go in the middle of the beam, and then these other ones that go slightly on top of them, they go on top of the columns. Okay, as you can see, we've got a column at the end, and then we've got another column in the middle somewhere there, as you can see there, and then we've got another column there. Okay, so we've got 3 columns, and on all 3 columns we've got these bars that go on top of them. Okay, so that's it. That's what I want you to understand about the slide. And then as we continue, now we are putting the top bars. Okay, you put the top bar. It's pretty much the same configuration as the bottom. It's also calculated the lap distance, but the configuration is pretty much the same. What I want you to notice is that the main bar comes slightly under the lap bar. Okay, that's what I want you to see. And then when you look from this view, then you will see this. So you can see now, you will see the main bar at the bottom, and then the top bars there. So this is the top bar that you see there, and that's the main bar. It's the main squeeze, the main bar right over at the bottom. That's cool. Let's move on. Don't worry too much about this. We'll get to it when we get to now design the actual bars. Now, this is the complete drawing. Now, what I want you to take note of is that they made a mistake over here. This bar here is supposed to come at the bottom. Okay, so you're supposed to have the same configuration. Oh, no, it's fine on top. Wait a minute. Something's going on, because this is the one that's supposed to be on top. They made a mistake. They were supposed to cut this one here, right over there, and put it on top, and then the bottom one just like that, so that the configuration should be exactly the same as at the bottom. Okay, but as you can see, we've done this systematically. We started with the main bar, and then we put the lap bar at the bottom, and then we put the lap bar again on the top. So each top you should put the lap bars, and then put the top bars right at the bottom of each of the lap bars. Okay, and then now we're getting into the stirrups. So when you look at this view, the front view, this is what you see. The stirrups will be actually all over there, like that, like that, like that, you know, just to at the different spacings. But when you look in this view, what you will see is that they look like this. Okay, you'll see that view and you'll see that they actually look like that. They're going all around the bars. What I want you to take note of is that they actually go on top. At the top of the top bars and at the bottom of the main bars, just to hold them together like that and squeeze them like that, as you can see from this view over here. Okay, so those are the stirrups. They're called stirrups. Let me just write that down, stirrups. Okay, that's what I want you to understand about the stirrups. They hold together the main bars and the top bars. They surround them, they curve them, they tie them around. Okay, so here we go again. The stirrup, 50 millimeter face of the column. So this detail is just to say that the stirrups are starting here, going all the way there, and then they end there. Okay, and then they start again from here, going all the way there, and they end right over there. Okay, so one thing you should notice about these stirrups is that they're not on top of the columns. Okay, that's why they're ending just before the column and starting again just after the column, and once again ending just before the column. Okay, number of stirrups, don't worry too much about the calculation, but this is just for the sake of understanding how you calculate. You know, that's basically the number of the stirrups. Most likely you'll be told how many of them you should put, but in the case that you have to calculate, it's also not so bad, because what you need to consider is the column width, the cover as well. So that's the cover. It's the column width. That's the total right there. That's the total length of spacing that needs to be covered. And then you've got there's the bar diameter. Then you just have to add +1 to the equation. It's just an equation that you have to add +1. You always have to do it. Then approximately 24 that you need. So you will put the number of them in front. Okay, so now that's the dimension, or rather the dimensions of the stirrup. As you can see, it's got A. So it's A this side. We've got B. So it's also B that side. That's why you've got that. As you can see, same configuration over there of the actual stirrup. And then that's why here then you have dimension for A and B when it comes to the actual stirrup. And remember, to get this amount here, you take the length of it, okay, and then you multiply it with the total number of them, which is 73, and then you will get this 108,000. And that's the end of it. Okay, now let me just go back to my face and stop showing this. I do hope that you understood everything that we spoke about, but in the event that you didn't, please make use of your local lecturer on campus.